Hello everyone. In this video, we'll be studying about insertion of dielectric slab on the effect cap- on capacitance of a capacitor or plate separation distance, or you can say that if plate separation is increased or decreased. Okay, so we'll take two cases. The first one, battery is connected, and the second one, battery is disconnected. Okay, or you can say removed. Right. Initially, battery is connected. Right. V naught. Resistance is, let's say, D. Okay, this capacitor is charged, okay, and having charge Q naught. So what results can you derive? Q naught will be, this is basically, you can say, a summary. Okay, this video, Q naught will be C naught into V naught. Q naught will be 1 by 2 C naught V naught square, right? C naught, it will be epsilon naught A by D, right? And epsilon and uh, electric field you can say V naught by D. Now, if a dielectric slab is inserted between the plates of the capacitor having dielectric constant K, okay, we are inserting a slab inside capacitor. Okay. Now, what will be the effect on the capacitance? Okay, the first thing, potential difference across capacitor will be V naught. There will not be any change in potential difference. Second case, capacitance will be Kc naught. Okay. Third case, if potential is same, okay, then electric field will also be same. E will be V by D, or you can say E naught. Okay. Fourth case, energy will be 1 by 2 C naught to V naught square. Okay. See, there is a change in C. Okay. It will be just a second. This will be C only. Okay. Now this will be 1 by 2 into Kc naught to V naught square. Okay. Now, so what you've got? See, this will be K into 1 by 2 into C naught into V naught square. This is actually U naught. Okay. And charge will be Q is equals to K U naught. Right. This is a case when a dielectric slab is inserted. The second case, dielectric slab inserted. Okay. The second case is plate separation is increased. Okay, without dielectric. Okay, plate separation without dielectric. Okay, so potential difference will be V naught. Okay, since battery is connected, capacitance will decrease. Okay, why so? Because C is epsilon naught A by D. Okay? Electric field, it will also decrease because V is constant. So if D increases, then E will decrease, right? Charge, it will also decrease. Energy, it will also decrease. Okay. Now, since Q equal to CV, okay, and capacitor is decreasing, so and V is constant, so Q will also decrease. The second case, when battery is removed, the capacitor is fully charged and the battery has been removed, right? See, in this case, the first one, dielectric insertion. What will happen? Now, in this case, charge will remain constant. Okay, charge will be Q is equals to Q naught, right? Now, capacitance, it will be equal to Kc naught. Third case, potential will change. it will be P is equals to P naught by K. Initial potential P naught. Electric field, it will be E naught upon K, right? And energy, it will be U naught by K. You can also derive these things, okay, via formula. And in this second case, means in this when battery is connected, plate separation is increased, right? So what will be the effect on charge? Charge will be equal to Q naught because battery is disconnected. Capacitance will decrease. Potential difference, now in this case it will increase. Okay. Electric field, it will remain constant because it is sigma by epsilon naught. And charges, there is no effect on charge. Okay. And energy is going to. So this was the effect of dielectric slab, insertion of dielectric slab, and separation of plates. Okay. In two cases, when battery is connected and battery is disconnected. In the next video, we'll be studying about symmetric circuit.